The field of physics is big. It is unfathomably, totally, vastly big. In fact, it's so big that we must first look small. Even smaller than the man near this extremely big, extremely complicated plane. And even smaller than this incredibly grainy version of the same man's face. Alright, this is embarrassing. Come on, let's go.
Hadrons are the components of an atom. For example, mesons, baryons, and antibaryons. Baryons and mesons are members of the hadron family. They are both composite particles. Composite particles are subatomic particles such as protons or neutrons that are composed of two or more elementary particles. Two of the most common baryons are protons and neutrons. In fact, they are the most common subatomic particles, period. Neutrons live an average of 15 minutes before decaying. Protons are fairly stable and have a lifetime that lasts at least 10 to the power of 32 years.
Hadrons are composed of three quarks. Quarks and antiquarks pair up in order to form a hadron. Quarks can be one of three colors: red, blue, or green. Antiquarks can be one of three colors: yellow, cyan, or magenta.
And then there are mesons. The meson is a very unstable particle, so unstable, in fact, that the longest time any meson has survived has been for a few hundredths of a microsecond. To give perspective, 1 microsecond is 1 millionth of a single second. Also note that mesons, much like many other subatomic particles, are mainly observed and emulated in labs, such as the laboratory in CERN.
There are over 140 types of mesons. They are each about 2/3 the size of a proton or a neutron, and charged mesons can decay to form electrons and neutrinos. An uncharged meson can decay into photons.